Hello everyone, this is my solution for a robot that needs to perform slam in a Webots world that has noise in it. So this robot has noise in the inertial measurement unit has 10%. Same for the position sensors that are on the hinges and the distance sensors. And something from my last video that I did not explain for a world that didn't have noise is how the robot is actually able to localize in a world without knowing where it is. So basically, in this scenario, the robot has no idea where it is. You can see by all these question marks, it could be anywhere. Basically, it needs to first find where it is by using these landmarks. So all of these cylinders are completely unique, completely different from everything else here. And we can see that we gave each of them this information over here, basically their coordinates and their radius. So from this information and from these color codes over here that are in RGB, we have a camera that's on the front of the robot that you can see. Well, this is as if it was facing that way, but if we here, so now it's facing this way. You can see there's like information that pops up. It gives a relative position from the robot's camera to this. So it's basically as if it were reading it. It's like shooting out a ray and it's coming back and approximating that information. So it can basically get its range from the cylinder to here by recognizing this specific RGB value. So while the robot is going through and whatnot, this one's going to go through this way, and we can see that it's going to get all the way up next to this, and it gives a relative position, and from that we can go up here. It just localized next to it. So basically it got all the way up here, saw that it was right next to the red cylinder, it was really close to it, and from that it's able to approximate that it's about at 1515. It's just, I hard-coded in values for each of these different corners in the center of these cells. So it's just going to go find a cell and assume that it's basically dead center in that cell, and from there it will go and map the rest of the world. So at this point you've seen about 3 videos, if you've gone and watched them, just of how it's going to go through. It's going to go this way, work its way back, and then since it's already seen this one and these couple ones, it will work its way around to here. So you can see that it's about to end right here. It just finished mapping all of the walls. It visited every single one. This was the last wall it mapped. And you can see that it thinks that it is about 4 inches down from this line right here, this being the x-axis. So it's about 4 inches down from the x-axis, and it thinks that it is approximately 16 inches from the y-axis. So it's about at 16 -4. So it looks like this noise solution worked. It was able to localize, and it was able to map all of the internal walls. Thank you.